Welcome to qnawire.
Hi, in the given problem, here this is the space having x, y and z axis like this. This is xy plane, which is a horizontal plane. This is the z axis. A loop is lying in the xy plane and the magnetic field is along z axis. So this magnetic field is linked through this loop. The radius of the loop has been given as 12.0 centimeter, or we can say this is 12.0 into 10 raised to the power minus 2 meter. The magnetic field in upward direction is 1.5 Tesla. This can be assumed to be the initial magnetic field because after some time the loop is removed from the magnetic field. In that case, the magnetic field passing through this loop will become 0. And this magnetic field becomes 0 in a time which is given as 2 millisecond, 2.0 into 10 raised to the power minus 3 second. In the first part of the problem, we have to find the EMF induced in the coil. So, using Faraday's laws of electromagnetic induction, the EMF induced in the coil is given as time rate of change of magnetic flux linked through this coil, or it can also be given as the change in magnetic flux phi 2 minus phi 1 per unit time. And as we know, the flux, magnetic flux, is given as the product of magnetic field with the area. So this phi 2 becomes P2 times A, area, and this phi 1 becomes B1 times area of the loop divided by time. This area comes out as a common, so finally we will have B2 minus B1 divided by time multiplied by area of this coil, which is pi r square. So when we put these values, we will get this is 0 minus 1.5 divided by 2.0 into 10 raised to the power minus 3 multiplied by 3.14 into 12.0 into 10 raised to the power minus 2 to the whole square. So finally, this value of EMF induced comes out to be 33.9 volt. This is the answer for the first part of the problem. Now, in the second part, if we are looking at this loop from upward, so the magnetic field will be coming out of this loop and this magnetic field is reducing. So the reason behind the induced EMF is upward decreasing magnetic field. So as per Lenz's law, the induced magnetic field should be as per Lenz's law, it should be in a direction opposite to this. So it should be upward increasing. So the induced magnetic field should be coming out of this loop and in increasing way, it should be increasing. So this upper face of this loop should start behaving like north pole, or we can say the direction of current induced in it should be counterclockwise. So upper face of the loop should be north pole, or we can say the direction of current induced should be counterclockwise. This is the answer for the second part of the problem. Thank you.